Section 1.3, factoring polynomials. The bottom line here is, why are we factoring? Because it's going to help us solve equations. You can read through the rest of this if you like, but I hope you'll get the gist of what's being stated here by way of example. So let's look at some examples now. The first thing is common factors, or you hopefully know it as GCF, greatest common factor. Let's go ahead and look at this example that's already been completed. Let's see why it works. So what you want to do first, and this is always what you want to do first when factoring an expression, is try to find a greatest common factor, the GCF. So the first thing you want to do is look at the numerical coefficients, all right, the numbers in front of the variable components. And what you're trying to do is come up with the greatest possible number that goes evenly into all of these numbers. And in this case, that would be a 6. After you finish that, you look at the variable components. If every one of the terms contains at least an x, then the greatest common factor with respect to x is actually the one that is base x raised to the smallest exponent. The smallest exponent. So in this case, it's x to the first, understood. Now, with respect to y, well, look at the middle term. You don't have a y here, so because that's the case, y cannot be part of the greatest common factor. So then how do you factor it out? Well, you write down the GCF, which we determined to be 6x, and you then decide, okay, well, what times 6x is going to get me back to where I started? Okay, so 6 times what gives you 30? That's 5. X times what would give you x cubed? Well, x squared, right? We already talked about that. X times x squared would give you x to the third power, because when you multiply like bases, you add the exponents. And then there's a y here left over, so you do include that as well. And so this is for all three. The bottom line is the GCF comes out in front. Everything left over will go inside of one set of parentheses. All right, so let's go ahead and do another one here. So let's factor out the greatest common factor. Okay, so we're looking at the numbers in front first. What is the largest number that would go evenly into both 12 and 16, if there is one? And yes, there is one. In this case, it would be 4. So we're going to write down 4. All right, now, do we have x's in both? Yes, we do. So we write down x to the what? X to the smallest exponent. So 3. 3 is, of course, smaller than 4. And then do we have a y involved in each of these? Yes, we do. So we write down a y. Now, y to the what? Y, again, to the smallest exponent, which would be 3. And then let's go ahead and just cut to the chase here. So 4x cubed y cubed is our GCF. This times what would bring us back to 12x cubed y to the 5th? Well, that would be 4 times 3 would give us 12. X cubed is already an x cubed, so you're finished with the x's. And then y cubed times what would give us y to the 5th? Well, that would be y to the 2nd. Okay? And then what? Plus, well, 4 times what gives you 16? That's 4. X cubed times what would give you x to the 4th? Well, that would just be an x, right? X cubed times x would give you x to the 4th. And then y cubed, we already have it, so we're finished. We factored out the GCF. Some factoring formulas that you should be aware of. Difference of two squares, perfect square trinomials, sum of two cubes, and difference of two cubes. These two are the ones you really got to memorize and be able to work with. Of course, the other ones you should know how to work with as well, but those can just work themselves out since they're just of second degree. They're just a little bit smaller and easier to work with. Okay, let's go ahead and look at some more examples. All right, so this is one of those trinomials of second degree. All right, So for us to factor anything, the first thing, again, we want to do is check for a GCF. Do we have a greatest common factor here? And no, we do not. Okay, so what we're trying to do here in this situation is actually undo the FOIL process. So, there is a formula that goes with this, but let's say we don't remember the formula. Well, that's okay. What we're trying to do then is look at the constant term 49 and think what two factors, what two numbers, in other words, when multiplied together, not only give us 49, but also give us a negative 14 when you add them. What two factors of 49, when added together, give you a negative 14? And those two factors would be negative 7 and negative 7. So I know I did that pretty quick, but the factorization of a trinomial is going to be the product of two binomials. Again, it's the reverse of the FOIL process. So first, x times x, does that give us x squared? It sure does. Okay, let's check this. That works. We're going to check this. Outside, x times negative 7, does that give us negative 7x? Yes. Inside, does this give us also negative 7x? Yes. And then finally, last, negative 7 times negative 7. That's the whole point. Does that give us a positive 49? Yes, it does. We have a pair of like terms here. So the check does work. We do get the trinomial we started with. Now, look, you're not going to take this long to do it. I mean, many of you are just going to be able to look at this and say, oh, well, what's the factorization? Well, it's this, right? Why? Well, because remember, if you have like bases, x minus 7, and you're multiplying them together, you add their exponents. So there's an understood 1 here, understood 1 here. So it's the quantity of x minus 7 squared. Honestly, if you just wrote this down, I'd be happy, or entered this into WebAssign, I'd be happy. This is what the formula would tell you it is, all right? Either way, doesn't matter. The bottom line is, again, to do what? Look for factors of this constant term and see if you can get them to add to negative 14. That is, of course, because the leading coefficient here is 1. We'll look at the factorization of more trinomials here in a little bit, okay? Let's go on to example number 2. In example number 2, are there any factors of 2 that can be added together to give you a 2? Well, the only two factors of 2 would be 1 and 2. Can you add those two numbers together, 1 plus 2, and get 2? No. Therefore, this is not factorable. So we say it is prime if it's not factorable. I know I spent a lot of time talking about this. I apologize. Again, many of you can look at this and just factor it in like 5 seconds. That's great. There is a formula for this, sure, but you don't need to memorize it necessarily. If you do, fantastic. Okay, moving on. Oh, 27x cubed plus 8. So this is the one that's based on that sum of two cubes formula. So go back in your notes, look at that sum of two cubes formula. All right. So what I do is recognize this is a perfect cube. Why? Because 3 cubed gives me 27, and x cubed gives me, of course, x cubed. I'm going to call this A, because, again, it's based on our formulas that we discussed. Let me find the formula here. Here is the formula. Sum of two cubes, okay? So, all right, we have A equals 3x. And now, what's the cube root of 8? B equals 2. We're just going to follow this model now. So this in factored form would be what? It'd be 3x plus 2, right? Because it's A plus B. Then the last part of this thing is going to be what? Well, it's going to be A squared, which is this thing squared. So 3x squared, the quantity of 3x squared is 9. x squared. And I like to do the first and the last term in this trinomial as I complete the factorization. So let's go ahead and do that now. B squared would be 2 squared, so that's plus 4. The first and the last term in this trinomial within the factorization of the sum of two cubes, they'll always be positive. The only difference, no pun intended, will be these two signs. So if you start off with the expression being positive, if the given is positive and you're factoring it, then in the first binomial, the operation will also be addition. It'll be positive as well. These two things will be the same. The difference will be right here. So if this is plus, this has to be a minus. That is what allows everything in the middle to get omitted to end up with this if you were to multiply these two expressions together. So minus what? Minus AB. So what's 3x times 2? That's 6x, so minus 6x. Finished. This is just one of those things that you just got to memorize and play with a few times, and then you should be fine with factoring a sum or difference of two cubes.